Okay, we're going to be looking at graphing absolute value functions. This is what our parent function looks like. It looks like this V shape. If you remember, absolute value always makes things positive. So anything that we would have put in for an x value that's negative flips to be a positive value. So this is how we get this V shape. Okay. It still follows that same pattern where we have the vertexes opposite of inside the, in this case, absolute values instead of parentheses, and outside it goes in the direction of the sign. So this goes the opposite direction horizontally and then the same direction vertically outside. So that's why we have that our vertex is at HK. The A value is always what affects our steepness. So in the absolute value, the steepness is the slope of the right-hand side. So it has to do with the right-hand side so you get the correct way. If A is positive, it's going to be opening up. If A is negative, it's going to be opening down. If your absolute value of A, so you're essentially looking at A without the sign, if that's more than 1, then it's going to be skinnier or a vertical stretch. If it's less than 1, it's going to be wider or a vertical shrink. Okay? So here, if we look at this example, this means we're going the opposite direction inside. So we're going right by 4, the same direction outside, so up by 7. So right 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7. Okay, this is our A value. That's the slope of the right-hand side. So we're going to go up 2 and over 1, and then I can mirror image the point because notice our absolute value graph has that symmetry, like our parabolas have that symmetry. So our axis is symmetry, so you can make points on opposite sides of that axis of symmetry, which is around the vertex. If you want more points, you can go up 2 and over 1, up 2 and over 1, right? And then you create your V shape. Now, your domain for this is that it's all real numbers for your domain, or negative infinity to infinity. And then your range, notice we have nothing below this Y value here, right? There's nothing there. So that means we're starting at this Y value and we're going up from there. So if we start our Y's at this value, so we're going from 7 and then up for forever. And since we touch 7, it's a bracket and then to infinity. If we look at this next one, we're going to do the opposite of inside. So we go left by 6, same on the outside, so down by 2. So left 1, 2, 3, 4, 5, 6, down by 2. This is our A value, which is our slope. So we go down 3, right 1. That's the slope of the right-hand side. And then you can mirror image that point, down 3 over 1, mirror image the point. So we get this is our absolute value. Our domain, your domain for all absolute values is going to be negative infinity to infinity. The other way you can think of it, is there any problem with a number that you would plug in here? No, there's no problem that I would come across when I plugged in a value here. That's the other way that you can think of it. Our range, notice on this one, we have nothing above in this vicinity. So we're starting from this, our Y value, and we're going down from there. So we always write our range as our low number to high number. So I'm going to start at negative infinity, and then the high number that I go is negative 2, and I touch it, so it's going to be a bracket. If we look at this last one, we're going to do the opposite direction inside, so right 2, same direction vertically outside, so down 9, so right 2, down 9. Our A is our slope, so remember that this means it's up 2 and right 3. So up 2, right 1, 2, 3, and mirror image back 2, 3, up 2, right 1, 2, 3, back 1, 2, 3. Right, and this gives us our absolute value graph. Okay. Our domain is negative infinity to infinity. The range, we're starting, notice we have nothing below here. Right, so we're starting at our Y value of negative 9 and going up from there. So our range is bracket negative 9 to infinity. So